Alright, here we go. We are talking about tangents. Today, you will use properties of tangents and solve problems using circumscribed circles. Actually, we're just going to mainly use the properties of tangents. Anyways, so let's start off with this. What is a tangent? A tangent is a line in the same plane as a circle that intersects the circle in exactly one point, called the point of tangency. Well, that seems a little redundant. But anyways, as you can see here, line AB over here is tangent to circle C at point A. AB and segment AB and ray AB, or whatever you want to call it, or line AB, are all also called tangents. In other words, I could say it's just a line segment. I can say it's a line that goes on forever. I can say it's a line that goes in one direction. Whatever. Point is, it touches the circle at one spot. A common tangent is a line, ray, or segment that is tangent to two circles in the same plane. Because why not? So in these two figures below, you can see here that line L is tangent to both circles F and G, no matter how they are drawn. Wow. Mind blown. Anyways, so it is also possible for, say, multiple circles drawn certain ways to have multiple lines of tangency. Have like more than one line tangent to both of them. So kind of keep that in mind. Anyways, we'll look at that more later, not right now. Theorem 10.10. In a plane, a line is tangent to a circle if and only if it is perpendicular to a radius drawn to the point of tangency. In other words, you got a line that's tangent. There is a radius that will touch that tangent point. It will make a 90-degree angle. And there you go. So how do I use that? Well, I'm glad you asked. So here we go. You can tell me, is KL tangent? Well, because, okay, and here's the reason why we say that. There is a way for us to draw these that they look like they're tangent, but they're not tangent. So, we want to test to make sure they are tangent. Now, how can I say that? Well, again, it's supposed to be making a 90-degree angle. So, if it's supposed to be making a 90-degree angle there at that point of tangency, then that means that I've got a right triangle, and I can say a squared plus b squared equals c squared. So I could do the a squared plus b squared equals c squared. But, again, be careful. I give you 8 squared. A squared is 8. B squared is going to be 15, or 15 squared. C is not going to be 9. Oh, you're being tricky, sir. Okay, keep in mind, 9 is from here to here. So, what's in between? The radius, 8. So, I'd have to add 9 plus 8, and that would become my C. So, 8 plus 9 would become my C squared. And then when I check those, I would get 289 for both of them. So that means it meets the Pythagorean theorem, which means it is a right triangle, which then means KL is tangent. It's like, what? In other words, I just needed to prove they were 90 degrees. So if a squared plus b squared equals c squared, it's a right triangle. And that means there's a 90 degree. Here's another example. Ooh, this one could be ugly. All right, so now I want to find x. I'm going to assume they are tangent. So I got to find x to do that. And this gets a little ugly. I will show you how to do the x plus 8 squared. Because, again, you need to start remembering that for algebra. Because some of y'all are going to be taking Algebra 2 next year. Anyways, the x's would cancel each other out if you move the x's to the other side. So I'd be left with 16x equals 80. And, again, I can show you all those steps later. And then you divide, you get x equals 5. So there you go. Here's a little bit easier one. How about this one where I just got to subtract them? So x squared plus 14 squared equals 17 squared. And then I could subtract or get 196 and 289, subtract and get 93. But again, after with this, you always got to take the square root. So we have square root of 93. And we'll leave it like that. I don't need no decimals. No decimals. I'm good like that. Alrighty, now what's next? I don't remember. Oh, theorem 10.11. If two segments from the same exterior point are tangent to a circle, then they are congruent. In other words, these two lines, AB and CB, originate here at B. They go from the same point. Boom, boom. That means they are congruent because they have the same point of tangency. There you go. Alright. So how do I use that? Well, I could do something like this where I could say, oh, hey, that means these two things are equal. X plus 15 and 2x minus 5 must be equal. So I can say 2x minus 5 equals x plus 15, and variables to the left, numbers to the right, and get x is equal to 20. Bam, bada bing, bada boom, and there you go. That's really all this is. I mean, again, notice how we're trying to use these properties in different ways. So we're trying to make sure we understand how we are using them. And that's really all it is today, folks. Let's see. Let's throw in an extra bonus word, see what y'all are doing. So why not have, what's a good one? Oh, I'm going to say orange. We'll just do something simple like that. Alrighty? Thank you so much for your time. Y'all take care.